Hey guys, welcome back. Today we are starting a new unit that is all about motion. So today our first intro into motion is something called a frame of reference. So without further ado, let's go ahead and jump into today's lesson. So before we move forward, I want you to stop and ask yourself, how do you know an object is moving? So if you're looking at an object, how do you know that it's in motion, right? If you yourself are moving, how do you know that you're in motion, right? A lot of you right now are probably watching this maybe with headphones on, sitting at your desk. Maybe you're moving your hands a little, maybe fidgeting, but really not up and walking around. So how do you know you are in motion or an object is in motion? Well, the answer is we have to have something called a frame of reference. We have to be able to compare the object to other objects that are not moving. So if we're looking at something that is moving or we are ourselves moving, our frame of reference is always going to be something that is stationary. And the best frame of reference will always be something that is sitting still, especially in relation to whatever object is also moving. You have to have a frame of reference, so a point where you can look at another object and tell that it's moving in relation to another object. So it's just a set of objects that are not moving. It's a reference point for us to be able to tell, okay, this object is moving. I can tell that it's in motion because in comparison to the object that's stationary, I can tell that it is in motion and it's moving. It has movement to it. And when we say relative to, that just means compared to. Okay, so let's say that you got up out of your computer chair right now, or if you're sitting at the kitchen table, wherever, and you decided to get up and walk around, make a circle around your computer desk, you would be in motion, and your frame of reference could be your stationary computer chair. So in reference to your computer chair, you would be moving around it, and it would be staying still, and that would be your frame of reference. And this is just a picture of a little torpedo that's making its way. And we could tell that this little torpedo, and I'll play this little simulation again, we can tell that it is in motion because we can relate it to, it looks like there's like an air base down here. It moves over the air base, which stays stationary, right? If we have like buildings that are built into the ground, those are staying still, and we can see the motion of the rocket, torpedo, whatever it is above it. So if we're looking at, like for example, here we have a little dragonfly and it looks like his little ant friend is catching a ride. If we're looking at this dragonfly that's flying around, the frame of reference would be this stationary flower here, and we can tell that the dragonfly is in motion because compared to this flower, it has movement, right? It's moving around, it's flying around, it is in motion while the flower stays still. Now, another thing to think about though is that all motion is relative. So if we take a look at this individual right here, it looks like she stayed up maybe studying a little bit too hard. She fell asleep. Now, if we look at her, especially in relation to the desk, if we say, is she moving? Well, our initial answer would be no, she's not moving, she's asleep. So compared to the desk, if your desk is your frame of reference, the desk is stationary and the girl that's asleep is also stationary, so she's not in motion. However, if we're talking about context of being on the planet, she is in motion because we are all in motion all the time because we live on the planet Earth that is both rotating on its axis and orbiting around the sun. So if we're talking about, let's say that she fell asleep, maybe she lives in a tropical area around the equator, she's technically moving at about 1,000 miles per hour. So again, it's relative to what you're talking about. So is she in motion? Looking at her relative to the desk, no, she's not in motion. She doesn't have movement, but she does have movement in the context that she's on planet Earth and the Earth is spinning and rotating through space. So here's another example for a frame of reference. It says a gray car and a red car are traveling down the street at 35 miles per hour. For the driver of the gray car, does the red car appear to be moving? And then B says, if you were standing by the side of the road, how fast would the red car appear to be moving? Okay, so let's think about this in terms of points of reference or frames of reference. If we're driving a gray car and a red car is next to us and we're both going at the exact same speed, then we're not going to be able to tell that that other car is in motion, okay? So the answer to that is no, because we're both in constant motion, and so it doesn't appear that the other car is moving anywhere, if that makes sense. Because relative to us, they're not going anywhere because we're in the same position. But if we were standing by the side of the road, then both of these cars would have movement and they would both be moving at 35 miles per hour. Because in relation to the cars are moving and we are stationary. We're the frame of reference and we can see that these cars are in motion. So to us, standing still or on the side of the road in a stationary position, these cars would both be moving at 35 miles per hour. In relation, if you're in the car, if another car is moving at the exact same speed, there's no motion because you're both in the same position relative to each other. So then let's take another example. A red car is speeding down a neighborhood street at 45 miles per hour. A police car is approaching the car and is traveling at a constant speed of 52 miles per hour. A says, how fast is the police car moving relative to the ground? Well, relative to the ground is stationary, right? So the ground's not going anywhere. It doesn't have a velocity. So the ground itself versus the police car is going to be 52 miles an hour, because in relation to the stationary ground, the police car is moving in total at 52 miles per hour. But B says, how fast is the police car moving relative to the red car? Well, this is going to be different because the red car is not stationary. The red car is moving at 45 miles per hour. So to find this answer, we just have to find the difference between the speed of the police car and the speed of the red car. So 52 minus 7 is 7 miles per hour. So relative to the red car, the police car is moving at 7 miles per hour. Okay, so it all depends on your frame of reference. And last but not least here, when we talk about frame of reference, we're going to make a little connection to earth science. So we talked a little bit about, we are all constantly in motion because we live on planet Earth, right? And the Earth is traveling, it's spinning on its axis, it's orbiting in rotation. But the most common frame of reference for describing motion is rotation around the axis. That's our Earth. Because of this rotation, something traveling in a straight line from the pole to the equator, such as a jet, wind currents, or ocean currents, they have a curve on them, and that's from the Coriolis effect. And hopefully we remember that in earth science, because I know for a fact you guys remember that, or learn that, I should say, in earth science. So that's just something to think about. Coriolis effect, frame of reference. Our planet is typically a frame of reference that we use, especially in astronomy, talking about the night sky and our orbits, etc. Okay? So the biggest thing for us to remember in terms of frame of reference is that motion is going to be relative to whatever you're referencing, right? So if you're standing still, like watching the cars go by, they'll have whatever mile per hour it says that they're taking on. But if we're in a moving vehicle as well, you have to remember that the difference in the mile per hour will just be, you subtract it to figure it out, okay? So this is just an intro to motion, talking about frame of reference. If you guys have any questions on that, let me know, and I will catch you guys in our next lesson.